Hi, welcome to the video on how to complete the flame test lab. For students who were in class, you can use your data that you got in class during the day of the lab. If you were absent that day, you can still complete this lab virtually. I will link in the Thursday folder a Google Doc version of this. You can make your own copy and type in your responses there. Or you can use the PDF version, also linked in the Thursday folder. All right, so let's go ahead and get started. So if you haven't done so already, if you've not done the lab at all, make sure you read through the introduction. I'm just going to walk you through sort of how we're going to complete it and the resources that you have. So let's begin with the resources that you have. You have access now to this document, which goes through for each question. I have the section of the lab that it corresponds to and the resources that you can use to help you complete the questions. So if you get stuck, you always have that as a resource. All right, let's look at the parts of the lab. So we have our pre-lab question 1, where you're writing the electron configuration and the number of valence electrons. So that's pretty self-explanatory. Again, if you get stuck, you can look at the resources here. Just note that for that pre-lab question, copper 2+ is a transition metal, so there will be separate resources for the copper 2+ electron configuration and valence electrons, but for the rest of them, you're using the same resource. So it's noted here, like it says used for everything except copper, and then here it says use this resource for copper 2+ only. So just keep that in mind. All right. The second question, question 2, you're going to use, of course, the image above on the electromagnetic spectrum. Don't forget you have to fill out what happens to the wavelength. Does it increase or decrease as you go to the right in the spectrum as listed here? And then you're also filling in the blanks, answering the question again using that image. For question 3 and 4, you're also going to use the electromagnetic radiation spectrum above. So question 3, you have this emission spectrum, and you're asked to identify the colors corresponding to each band. So you have a band here at 410 nanometers, 434 nanometers, 486 nanometers, and 656 nanometers. And underneath each band, there is a line, and that's where you'll type in the color. So to figure out the color, you come back up here and look at the visible region of the spectrum to help you figure that out based on the wavelength. That's in nanometers. So let's say, for example, for band 410, I think that I look at my electromagnetic spectrum and I say, oh, that corresponds to green. I'll just write green underneath that band. So the first line corresponds to the first band on the left. And you do that for the rest of them. So that's how you answer question number 3. Now, by the way, I'm not saying green is the correct answer, but this is what your work should look like. So underneath each band on the line, there should be a color. All right, for question 4, what you're going to do is you're going to use this emission spectrum and your understanding of electron transitions and the energy of the emission spectra to help you figure out which of these transition lines correspond to which band. So you'll notice that there are 5 transition lines, but there are 4 bands. So one of them you're not going to use. So a couple of things you want to look out for: the energy gap of the transition and how that relates to the wavelength of light for the band. The other thing you want to look for is the direction of the transition. These, in question 4, we're looking at the emission spectrum. So which direction would the electron be traveling? Will it be dropping down or jumping up if it's an emission spectrum? And then once you figure out that information, you're going to simply write the letter next to the emission band. So for this band 410 nanometers here, which transition corresponds to it? Is it transition A, where the electron jumped from the second to the first energy level? Is it B, when it jumps from the fourth to the first, etc.? So whatever one you think it matches, you're going to write the letter here. So if you think it's B, you type B here. So these should all be filled with letters of the transition. Okay, now let's go into the data section. So again, for folks who were absent and you didn't do the lab, you will use the links to write down your observations. So for each of the metals, there are two types of colors that we observe. First, we took the metal and we placed it in the Bunsen burner flame, and we just looked at how the color of the flame. So if you were absent, or even if you wanted to check your work, if you were there, you click on the link and it'll take you to, oops, this is a video. Okay, we're back. Sorry about that. So it will take you to a video, you watch the video, and then you write down the color of the flame. So this one is for sodium, and you see the color of the flame looks like yellow-orange. So that's what you would, oops, where am I? So for sodium, you would write down the color of the flame. So again, yellow or orange, whatever color you saw. Then what we did during the lab was we watched or observed the flame with the spectral glasses on, and it sort of breaks up or diffracts the light. And so when you click on that, it'll take you to an image that shows the diffraction spectrum. So on the left, this is what you would see with your glasses, and I see like a bluish color here, or maybe a indigo color. Here I see green, I see yellow, and I see red. So those four colors, blue, green, yellow, red, I would write that here. So blue, green, yellow, red. Now, if you did do the lab and you want to check, because I know the spectral glasses was a little difficult to see, and you're not sure if you have the right colors, you can just use the data in the emission spectrum here. So once again, you have access to that. If you need to, you can look at the diffraction spectrum, record the colors. I also provided the emission spectrum. So this is what the emission spectrum of sodium looks like, and you should see similar colors. So notice how with the diffraction spectrum you see blue, and there are two blue lines. This line here looks like yellow to me, but it's between blue and yellow, which would be green, so maybe that's why this appears green. You have a very strong yellow, and that is what we see here. The most intense color is yellow. And then you have some sort of red or orange color. So you should notice that for each of these, the diffraction spectrum and the emission spectrum should have the same colors. All right, so once you've gotten that filled out, the observations and colors for the known elements, you also have an unknown. And once again, you would click on the unknown, and in this case, the flame is, there's not a video, it's just, you just look at the flame and you record what colors you see in the flame. And then the same thing with the diffraction and emission spectra, you record those colors. And using these information along with the known elements, it will help you to identify your unknown. Now you notice that the emission spectrum here has a mix of different things because your unknown is a mixture. So you have to figure out either from the diffraction and or the emission spectra which element could be in your unknown. So for your unknown, everyone has to use the data that's provided because we didn't do that in the lab. All right, now we're going on to the post-lab questions. So for the post-lab questions, once again, you're going to use the information that's linked in the resource list here. So they'll be listed for the itemized resources. You find the correct post-lab question and it'll give you resources to help you. And the last post-lab question, which is a good chunk of your points, is describing the emission spectra, how emission spectra are created. And it says use this reading, which you can use that, or today's slides. So once again, in the resource document, I will list the slides there because there's no link for the slides. So I'll list the slides that you want to use. You could also use a reading if that's helpful. Don't forget to follow this checklist. It shows you how the points will be distributed for this question. So you want to make sure that you have this somewhere with words and pictures. Okay, so you're using both to describe what's happening. All right, if you have any questions, please don't hesitate to reach out. I hope you found this video helpful. Good luck with your work and have a quality weekend.